The coefficient of variation, also called the CV, measures how spread out data is relative to its mean, expressed as a percentage. It helps compare data sets with different means or scales. The CV is calculated by dividing the standard deviation by the mean and then multiplying by 100 to express it as a percentage. To find the sample CV, you divide the sample standard deviation by the sample mean, and to find the population CV, you divide the population standard deviation by the population mean. Imagine you're comparing the test scores of two classes, where the first class has a mean of 70 and the second class has a mean of 90, but both of them have the same standard deviation of 10. It's hard to tell which has more variability just by looking at the standard deviations because they are the same, but with different means. The CV helps because it compares the standard deviation relative to the mean. The CV for the first class is 10 divided by 70 multiplied by 100, which equals 14.3%. For the second class, the CV is 10 divided by 90 multiplied by 100, gives us 11.1%. As you can see, the second class has a lower CV than the first class, which indicates that the data points in the second class are closer to the mean with less variability. This suggests that more students in the second class perform closer to the mean, which indicates a more consistent level of performance. This could mean the teaching methods or learning environment in the second class are more effective or uniform, as most students are performing at a similar level. In contrast, the first class has a higher CV, means the data is more spread out from the mean, indicating greater variability. For the first class, the scores are more dispersed around the mean, with some students excelling and others struggling, leading to more inconsistency. This could indicate that this class has a wider range of abilities, or there are factors leading to less consistent performance, such as differences in teaching methods, student engagement, or other external factors. Understanding CV in this way helps identify whether a class is more homogeneous or whether students' performances vary widely, which could inform decisions on teaching strategies, interventions, or areas that need improvement. In this example, we're comparing variation of height and weight of same adult males in different scales. For the height, the average height is 174.12 centimeters with a standard deviation of 7.10 centimeters. For the weights of those same adult males, the average weight is 85.54 kilograms with a standard deviation of 17.65 kilograms. To figure out which one has more variability, we need to find the CV, in which we divide the sample standard deviation by the sample mean and then multiply by 100 to express it as a percentage. The CV for the height is 7.10 divided by 174.12 times 100, which equals 4.1%. The CV for the weights is 17.65 divided by 85.54 times 100, which equals 20.6%. We can now see that the CV for weights is higher than the CV for the heights, which means that the weights of adult males are much more spread out compared to their average weight, while their heights are more consistent and closer to their average height. In real-world terms, the higher variability in weights means weights differ significantly between individuals while their heights are generally more similar. If you're designing fitness programs, you will need to account for a wider range of weights, but can expect less variation in heights. When designing clothes like shirts or pants, weight variability might require a wider range of sizes, where areas height could be addressed with fewer size options. In healthcare, understanding the variability in weight is crucial for things like dosing medication or assessing health risks, while height might play a less variable role. In the end, CV highlights where differences are larger and helps in tailoring solutions to fit the population.